Welcome. This week's video is about geography. I've had some issues with the recording of this is why it's a little late, so I'm hoping that the third time is in fact the charm. First of all, I want to talk about geography as a fusion discipline. Geography draws from many different areas of study. There are, however, two large branches of geography, and those branches are called physical geography and human geography. Human geography is sometimes referred to as cultural geography. No matter what branch you're looking at, geography is always interested in the spatial distribution of things. In other words, where things are across a location. That might be the entire Earth, or it might be some region of the Earth. That could be a region like a continent, it could be a cultural region, it could be at the state or local level. So, for any of these things, we could talk about the physical geography of the entire Earth, or we could talk about the physical geography of Minnesota. We could talk about the human geography of Earth, or we could talk about the human geography of Europe, or South America, or China. So, physical geography is looking at physical characteristics, and in physical geography, we have a lot of overlap with the sciences. And so we see that in the physical geography, we see overlap with earth science, with meteorology, with climatology, and with geology. So, meteorology, of course, is the study of weather. Weather is what's happening outside right now. Climatology is the study of climate. And climate you can think of as weather over time. So, regardless if the current weather is um, dry or moist, the particular climate might be an arid climate in, for example, the desert southwest of the US. And then, of course, geology, of course, the study of things like rocks and minerals. In earth science, that part of physical geography, you're looking at things like volcanism, plate tectonics, continental drift, things like that. It is important if you're doing a lesson plan in geography that your objectives are actually geography objectives and not science objectives. Of course, you can use both, like you can bring them together. You can do interdisciplinary work, which is awesome to do. But you just want to make sure that if you are teaching a geography standard, you are looking at, again, um, spatial things. So in geology, we may just look at rocks for the sake of looking at rocks and minerals and identifying them. In geography, we're really looking at where are those types of rocks distributed? Like, where are we more likely to see um, basalt versus limestone? Human geography or cultural geography looks at studies of culture, and this draws on anthropology. There's a lot of overlap between human geography and some types of anthropology, the study of humans. It also has overlap with other areas, predominantly the social studies. So we have things like economic geography, historical geography. That might be where people have lived over time and how boundaries have shifted over time, or how borders have shifted over time, how cultural groups have shifted over time. Political geography, so we might look at where democracies versus non-democracies are across the globe or in a specific region. We might look at the state level of what cities use a mayor, a council mayor form of government compared to a city manager form of government. Population geography is also called demography. This is where people live, how many people live there. There are also many others. So geography is one of those things that we can draw from lots of fields. There's medical geography, for example. And so geography is often associated with people looking at maps and globes. And you might remember your own geographical excursions in K-12 as being overwhelmingly focused on maps. And I think maps are important and being able to identify where things are on the earth are important. I think it's especially important for a future teacher. Um, but geography is a lot more than that. But the most common tool used in geography are in fact maps and globes. Globes are accurate, or they can be accurate, because the Earth is a three-dimensional sphere, um, roughly, not quite a sphere, a spheroid. A globe, it can be an accurate model of that. But a map will always have distortion because you can't take something that's 3D and make it 2D without some distortion occurring. And the distortion is going to be in at least one of these types. It's going to be a distortion of area. And so an area is basically size. And so some projections make certain regions look much bigger or smaller than they really are. That typically is by the poles. And so the most common projection that is very unpopular amongst geographers today is the Mercator projection. And on this slide in the top left corner of the image, you see the Lambert conformal conic projection, which is similar to that. This is a projection that makes items at the poles appear much bigger than they really are. So for example, Greenland on this projection looks like it's bigger than South America and nearly as big as Africa. It's far bigger than Australia. That's not accurate. Greenland is not bigger than any of those places. Greenland is the world's largest island, um, assuming that Australia is a continent, not an island, but it's definitely not bigger than Australia. So this is because this particular projection was not trying to preserve area, it was trying to preserve distance and direction, because it was originally used, the Mercator projection was originally used for sailors going from point A to point B across the Atlantic or across the Pacific. And so direction and distance can also be things that are distorted, and the shape can also be distorted. So in some of these projections, and this is hard for this particular image because it is these are not high resolution images, but in some of these projections for like the azimuthal equidistant and the Winkel triple, um, Greenland's area is much more accurate, but its shape is not. So some projections, this is a compromise projection, but it is one that is trying that does have issues with shape when you get nearer to the poles. So the different projections that exist, and there are literally dozens and not hundreds of projections, are attempts to preserve one or more of those features. And if you want to know more about projections, the link in the PowerPoint that you can access on D2L will take you to that. You can also look if you're interested in this PowerPoint video. If for some reason this video isn't available, there are tons out there. If you just look at map projections, that will show you how that occurs. You don't need to look at those things, but you can if you're interested. There are essentially two major types of maps. Those are physical or political. This is also true for globes. A physical map or globe predominantly shows physical features of the Earth. So in addition to things like rivers and lakes, and large lakes like the Great Lakes are going to be on any map of the Earth, but you're going to see maybe smaller lakes. You're going to see them labeled. You're going to see mountain ranges. You might see on a globe elevation indicated through coloration. A political map predominantly shows just political borders. This is the type of map or globe where every country is colored a different color. Now, both of these sometimes will have some aspects of the other. So some political maps will still show major physical features, and some physical maps will still show things like country boundaries, although some won't. Other types of maps would focus on things like culture regions. That could be things like religion or language or other aspects of culture, where natural resources are located, elevation, climate maps, and so on. In general, a good map is going to have 5 elements. And for some of these, you're going to want to reinforce these in elementary school. A good map will have a title. A good map will have scale. Now, scale might be something that is hard. That scale is a little tricky. We're going to talk about more about that on the next slide. But a good map should have scale on it. We need to teach children at least how to read scale. A good map will have a compass rose, and a compass rose indicates what direction, traditionally, what direction north is on the map. And so north can be on any direction. So traditionally, sorry about those horizontal lines. Traditionally, north points towards the top of the piece of paper the map is on, but it doesn't have to, as long as it is indicated. So in this second example I'm drawing here, north is going to the right of the paper. You could have north going to, the top left of the paper. Whoops, not northeast, north. So it doesn't matter where north is, but it needs to be there. Now, if for some reason north is not indicated on a map by convention, the direction of the arrow will tell us where north is. So if I just had this arrow, this is going to say, oh, it's north. Now, a compass rose can be much more detailed than this, right? It could have the 4 cardinal directions indicated of north, south, west, and east. It could also have the other intermediate directions shown, like southeast and southwest and northeast and so on. But there should be a compass rose, or at least an indicator of where north is. There should be a legend or key showing what references what. So one thing you might do that's a really cool thing to do, in fact, in elementary schools, to have students do mental maps and have them draw a mental map of something they're familiar with. That might be a mental map of their neighborhood. It might be a mental map of showing how they get to school, their route to school. It might be a mental map of the school playground. Um, Anything that they're familiar with, and then they can say, "Oh, here's my key. A tree means there is a park there." Um, or this a block, like a square rather, a square on the map means maybe means there's a stop sign there. And then something that your students are probably not going to use, but that you should look at, is a source for a map. A good map will have a source that shows where the data comes from. Where the data come from, rather. Oftentimes, professional maps will have either a grid or markings of latitude and longitude on them, which we'll talk more about in the next video. And then the last thing I want to talk about in this video is scale, which I mentioned in the previous slide. Scale is a ratio. It's a ratio of the distance on the map to the corresponding distance in the real world. Scale can be with or without units. If there's no units, that means it's the same unit for each. If units are indicated, then you could switch units. So for example, you might have a scale of 1 inch to 100 miles. That means 1 inch on the map is 100 miles in the real world. You might have a scale of 1 inch to 2,500 miles. That means that 1 inch on the map is 2,500 miles in the real world. You might have a scale of 1 centimeter to 50 meters. 1 centimeter on the map is 50 meters in the real world. If units aren't given, that means it doesn't matter what the units are. So for example, a scale of 1 to 37,500 means that 1 inch on the map is 37,500 inches in the real world. 1 millimeter on the map is 37,500 millimeters in the real world. 1 centimeter on the map is 37,500 centimeters in the real world. 1 foot on the map is 37,500 feet in the real world. For these ratios, the first number in the scale will typically be the number 1, and I would go so far to say as it probably should be, although I'm not an expert cartographer. You should know the difference between a small scale and a large scale map. A small scale map shows a large area and it has very little detail. So a map of the United States is a small scale map. A map of North America is a small scale map. A map of the world is a small scale map. A large scale map shows a small area with lots of detail. So the map of a city is a large scale map. The map of a neighborhood or a community is a large scale map. A map of a school is potentially a large scale map, right? You're going to show classrooms and stuff like that, where you wouldn't see classrooms in a school on a small scale map. All of these ratios can also be written as fractions. So for example, the scale 1 to 37,500, we can write any ratio as a fraction. And so that is 1 over 37,500. When we write it, this only works if the units are the same, right? I have to do 1 inch to 100 miles. I would have to change miles to inches to write this as a fraction. Which I could, right? I would multiply 100 times 12 times 5,280, and I would get a really, 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 really big denominator. The bigger the denominator, the smaller the scale. In other words, the bigger the denominator is, as long as we have a unit fraction, a fraction with 1 in its numerator, the bigger the number in the denominator is, the smaller the fraction is, and the smaller the scale is going to be. In other words, the bigger the map area will be. Then that might not be the map itself, right? It's still it fits on a piece of paper, but it's showing a large area on the Earth. So in our first video for geography, we talked a little bit what geography was. We talked about its spatial orientation. We talked about its two big branches, human and physical. We talked about map projections and how maps always have some sort of distortion in them. We talked about elements on a map, including titles and compass roses and keys or legends and scale. In our next video, we're going to go on and we're going to talk about latitude and longitude, and hopefully we'll get as well to some of the themes of geography. Thanks for watching, and if you have any questions, please let me know.